All right. Hello, everyone. Hopefully audio is working. All right, so this is going to be my first time doing something like this. I'm going to be streaming this on Twitch for the first time, but also on YouTube, Facebook, and Twitter. So what this is going to be a test for me to actually do some live coding for something that's going to be pretty, hopefully, simple and be public and be like an open source library. I'm probably going to repeat this explanation many times, but hopefully you can tell me in the comments if audio is working, if you can see me and hear me. Generally, what's going to happen is I will try to give some background on what's going to happen here. But this started for the need to create a cross-platform audio drivers library. Those libraries in general exist, but there's a few different issues with the current implementations that exist. Some implementations like Juice require a commercial license, and some people don't like that, even though we're using Juice in our code, and I'll probably create some interface between this and Juice. But there has been brought up a need to do something else, to have something that's separate, that can also be very easy to use and very easy to work with. Yeah, so I think that this is going to be like some of the design goals here. So the first thing we're actually going to do here, I'm going to wrap another existing library called RT Audio, and later RT MIDI once I finish with that. This library is already widely used. It's very good. It's open source. But I think that the API on it is kind of rough to use. Like, it takes a little while to actually get a sound. There's a bunch of like pretty raw callbacks and raw types and stuff that you have to work with. So I'm going to be, and I have actually done a little bit of work before I started this, but I did some work on wrapping this into like some clean API. And later, once I get this cleaned up, and this will take a little while, I'll probably will have maybe multiple backends so that you could use a Juice audio device manager or something like that instead. So yeah, so hopefully people are hearing this, seeing this. This is going to get quite technical, so I'll be looking at your comments and seeing if people have questions. I'll definitely try to, if people have questions, I'll try to go into like tutorial mode as well and to explain why I'm doing something. This is also going to be an interesting experiment for me because I've never done this kind of live coding. I've done live stuff like tutorials where I kind of was knowing what I was going for. But in this case, I know the result generally, but I don't know what problems I'm going to run into. I'm going to read into, third-party libraries like RT Audio, RT MIDI. I'm going to run into weird things. Who knows? This is going to be an adventure to make this happen. The history behind doing this is that I was talking to Julian Storer, Jules, who's the person behind Juice, the original Juice. And he told me about this need to have something that makes this easy to use and kind of coherent. And he's shown me also an implementation, an open source implementation that he's done around the same library in C major in his audio language. But he suggested that it would be nice to kind of have it isolated, separate, and wrapped in clean APIs to use for interaction from an app. So a few things that he talked about was, for example, you have an audio driver in an app and you want to change the audio driver, right? You want to select another interface. So there's something involved in how you make the change or recall a change or recall a preset of something that has been there previously. Yeah, so Eyal Bar says the code is in a small window. That's yeah, I will be showing the code on the full window. So it's going to look something like this. And I will be probably be zooming on certain things as I will show the code. I will just finish doing like my little introduction before I dive into actual coding. So basically, okay, so let's go back and let's start to dive into the low level details of this. So RT Audio is an open source library. I got it from GitHub. First thing I did, and I did quite a few things in here already, so I will just be doing an overview, but I will be going in depth on every single element here. So don't worry about like that. You can see that I'm literally midway through now. Was just doing some experiments. But first of all, I already have an example here that tries to make a sound using the minimum amount of lines. So this is in the entire main program. It calls my wrapper. My library is called make a sound. So what I do is, just to give you some general overview, is that I bring up a device manager. This is my object that wraps RT Audio in it. Then I get the config. I set up the callback, and then I open the stream. And once that happens, I just do a while true so that nothing's going to happen on this thread. On another thread, this audio callback, which is basically a very simple program making white noise. So you can see that it goes through the different outputs. So there could be multiple outputs, and for each of them, it just sends out a random float. This is basically the simplest way to make sound be heard. And this is the idea of a user program that uses this, right? And it's not ideal. This API is not good. I'm going to improve this API quite a lot as we work with this. This was just the basic API that I got to that had some sort of basic setup, but this will not be how people use this library, hopefully. So that there'll be much nicer ways and nicer interactions. But I think this is still nicer than raw working with something like RT Audio directly or Jack or something like that directly. So I'm going to play something. Hopefully you're going to get the sound. I'm just going to run this program. Let's see if it builds. There's a warning there that I should fix. So hopefully now you're hearing. I'm going to see what you're hearing. But hopefully you're hearing now that I'm playing white noise. Might be pretty loud. I'll make it soft so that your ears won't die. Yes. Okay. So that I don't want to do too much because there's nothing very interesting in this audio I'm playing. But the idea is that I got audio to work. This actually plays audio through my default audio device, which is my RME Fireface, and then kind of streams it back out to you. But it is like going through the input devices, or the input and output devices, finding the right type that's appropriate for this and all that. Okay, so let's see what we can do here. Now I'm going to start by, I'll go through a little bit of what I've already done, and be warned, it's a mess. It's going to be, I've done it just to get a good idea. I've done just to get a good idea of what the library is going to be about. I never had any experience working with drivers directly. Usually I've used something like Juice that gives you like an API around these drivers. So let's start. So what I did was, I created this device manager class, and currently this device manager class, I was trying to make the API of it close to what RT Audio is using. I will go through all of this pretty soon. Let's show this in full screen. Good. So or let's do this maybe. Nice. Okay. So I'm going to be wrapping this still with much nicer API. Currently, I was trying to map almost one-to-one with how RT Audio works. So you see a lot of calls here, like close stream is just calling manager, right, which is RT Audio, an RT Audio object. just calls it, right? This is like the most boring forwarding that you can do. I take it, I call it. I'm probably going to remove most of these, because those, in my opinion, don't really belong in a nice API. There's nicer ways to wrap it, but I just did it for the first thing. The more complicated things that I'm doing is when I do something, well, the audio callback, open stream, there's a bunch of setting up to do with how to set up the callback, how to make sure that the callback is called to the user later. We'll talk about that. Stuff like the config is doing a bunch of type passing, let's call it. So I created this thing called a stream config, which is an object I created to kind of mirror similarly to how the RD audio object looks like. I'll show that to you in a second. But I was trying to change it a little bit to use stronger types in more modern C++. For example, the original RT audio object. Let's see what the thing is called. So when I do something like this, let's see. Oh, there it is. When I do open stream and I do something like the end call there, it's going to be like manager open stream. This is the RD audio function. That thing calls or requires a bunch of different types. Like, for example, there's this thing called stream parameters, right? That thing is just 3 unsigned ints: device ID, channels, first channel. Let's go back. It also does something like, requires something like, like format, right? RT audio format, which is a type def for this thing. Like, so you can have, when you call the audio can be passed by integers or by 32-bit floats or 64-bit floats, more known as doubles. So there's a bunch of different options, and they've done it as just an int. So I was trying to do stuff like take this and make it stronger typed so that it's easier to work with and has less errors. So in my type, let's see if I can find my type in there. Let's see. So when I passed my type, I did something like format. Here it is. So I used something called format, which is an enum class, stronger typed, a little bit more difficult to make mistakes in. So when you set it up, and let's say you want int16, you don't need to find something you're going to get a compile error if you've used like the wrong number. So that's going to be easier. Other things that it did was that there's an optional element here, and we'll see if I actually keep it later. But there's when you pass this thing into OpenStream, into this RT audio call, then there's they ask for something like a pointer to stream parameters, and that pointer is there because it could be null. Like, you could actually legally pass a null pointer or pass no stream parameters if you don't want any inputs or outputs. If you ever interested, all of these appear on the API. Like if I go to RTaudio.h, those things are actually OpenStream. I'm going to find that function. There it is, and it's actually documented very well. So they documented that, for example, for input-only streams, this argument should be null for outputs, and same for inputs. So they gave some more documentation-based thing, and I wanted to avoid it for a number of reasons. One is that I think it's kind of an old-fashioned API. It's very hard to misuse. But also that a pointer usually requires the user to do some lifetime handling. So the user has to keep this alive beyond the scope of calling this function if they do pass, that information in. So it's very hard to make mistakes, to me, in an API like this. So I wanted to do something that's more C++-y. There will be some ugliness in my code that's going to happen to make my type fit into this. That's going to be a common pattern, but the user code will not have to be aware of something like allocating memory before and making sure it stays alive after. The user can work with more by value objects that are simpler and are less error prone. So that's an example. There's quite a few other things here that, so you can see this big function, OpenStream, is, in my opinion, quite low level. It's got something like RT audio callback, which is a function pointer. And it's quite a difficult to use function pointer, which we'll go over a bit later. So there's a lot here that I wanted to wrap and kind of switch to my own types. And I even think this type is not good the way it is, but we're going to talk about what I don't like about this type I made. But the good thing is this type ideally is meant to not include any of the RT audio types. It's meant to just wrap this in types that are defined in my library, so that in the future there could be different backends. Like a Juice could be a Juice audio device manager could be a backend, and I will do some mangling of this type into the Juice types in the library without the user having to change much in the way they interact with this. Okay, hopefully people are watching, and if there's any questions, let me know in the comments. Like I'm definitely going to be reading the comments to go through and re-going through anything that's not understood. I do know that I'm using some types here that some people have never used, like std optional, and there's going to be a lot of C++ types here that might not make sense if you've never used them, but hopefully I will be making them make sense. Okay, so here's what I'm going to do right now. What I'm going to do first is I'm going to. I can make this. Let's see if I can make this text a bit larger so that people can see more. Let's see, it's something like here. I used to have a shortcut for this. Didn't I have a shortcut for this? This makes font size bigger. I forgot what it was. Maybe I don't. So then let's do something like font and do something like 18. Hopefully that will make it a bit clearer. I think this is a good enough size, at least for me, to work with during the stream. Okay, so here's what I'm going to do. I'm going to start by starting separating some files, just so that I'll have clarity on the things I've done, because I kind of made it kind of a mess. The file structure here honestly makes no sense. I just did it to get things out. It's not correct. So what I want to do first is, you see I have this folder called include. This is starting at least as a header only library, by the way. So I'm starting to just work with just .h files. So I need to start cleaning things up. So there's an actual interface in here, and there's like normal types that make sense. Let's have a start. So I'm going to go into RT Audio, and I basically stuffed like the world in here. Like this, half the stuff are not RT Audio. It's just, I know, some crap that I put in there. Here's something that I did, for example, that's really bad. I have this type called device info, which is mine. But then there's an RT Audio format in there. That's not gonna work well, because the user might not be using RT Audio. So okay, let's start. Let me start creating a bunch of types here and eventually do this. First of all, I have this function here. This is kind of weird. This is something I made quickly that tries to convert an RT Audio device info into my device info just by copying everything. I don't like this to be as a constructor, because I want to move this type away from here. I can see this is kind of a basic type, and I need to clean it up and really separate what's RT Audio and what's not. So first thing I need to do, I would need to, instead of making this a constructor, I would make this a function. So it would be something like device info, get info or something, and this would take an RT Audio device info by const reference info or something. I can remove this, and all of these are just going to be like something like device info results, and this is going to be something like this. So this is just going to set these things in the results from things in here. And pretty soon this is going to be important because these are going to be moved into different files. This struct, which now does not need even this default constructor because it's just a boring struct. This struct will be open or exposed in the library. It's going to be a library object, and this is going to be something specific to the RT audio implementation, which I have not done yet. So let's just first of all compile, because I've used this constructor. It's going to fail to compile, going to tell me something like, hey, does not return a value. Oh, that's right. I didn't return the result. Very good. I also got this thing, says here. Here I was trying, this is one of the uses that I've had of this constructor, and now instead of going to use this, I'm just going to do something like manager get device info, and then I need to say get info, right? So it's slightly more code. Oh, sorry. I need to do this, right? Get info here and close this. So this is slightly more wordy on the call side, but it would help me separate this same here, separate this leaky implementation that I made by very quickly sketching this out. Okay, so hopefully this would build. Warning, no portable path. Oh, that's interesting. I probably should be able to do this, right? Ah, that's interesting. RT audio? No? Oh. Do these quotes instead. What's wrong with that? This should be in my include folder, and this says oh, that's interesting. Yeah, because this is not going to be RT audio. This is just going to be this probably. Yes, that's better. That's going to compile on other people's computer. Okay, now I have all these bugs that are related to my code. So vector of device info. Oh, great. This has to come from. Oh, right. Now I think there's a problem. I have two files called rtaudio.h. That's probably a collision that I have with two files with the same name. I'm calling my file the same way as the library file. Let's change the name of this file to make much more sense. Let's do something like rename and call this, how am I going to call this? RT audio backend. It's a horrible name, especially for what this includes. But so this is going to have RT audio this, and this backend is going to bring in RT audio. Let's see if this is correct. Good. Built, no warnings, no errors. I'm just going to commit this and say something like, fixed device info to be separated from the equivalent RT audio type. Great. Let's see what's going on now. So I'm going to go. Next up is I'm going to go into this device info thing, and I did notice this problem here. This is the problem I'm trying to solve. This is a struct that's mine, but it has one type that's a library type. I hate that. So let's analyze what this type is, RT audio format. Oh, look, I've already made this type. I've made it for something else. So I can just replace this. Native formats. What does it mean that it has native formats? That's interesting. Oh, it's a bit mask. Ah, interesting. So this is not a single format. This is multiple formats that are using bit masks to work with. So I'm going to basically do something else. I'm going to do something like, let's see how I'm going to do this. I do have a type called format. It should be right here at the bottom where I've made this blah, 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 blah. Here it is. Format in int 8, int 16, int 24. But I'm actually not sure this type is going to work with this because what I need basically, I don't like bit masks. I know that you need them for some system level stuff, but I think they're not very friendly to use. They're hard to debug. Yeah, so I think probably what I need, I could either create a vector of these so that you have a vector format that you can add to later. That's going to be, yeah, you know what? Or I can do something. Let's going to do something pretty, probably not the most efficient implementation, but I'm going to do something. I can either do something like a map. A map would be fun. A map could be fun, but maybe not. Maybe it's too complicated. It has heap allocations. I don't know. Let's do something else. Let's just spell it out directly. So I'm just going to do something like, instead of doing native formats, I'm going to do something like native formats, right? I'm just going to write the most boring structs that is. I need to fix something here. Let's invalidate my caches because I changed the name of the file. CLion gets confused. Okay, so there's a question here while I'm doing this. Let's see if I can show the question. Okay, so this is a question from Ayal Bar. Says, question out of topic. Will you make some tutorial vids in the future about how to create VSTs? The answer is yes. And I have done a few of those. Like if you go to my YouTube page or the Audio Programmer YouTube, there's a few tutorials that I made regarding making plugins. I also have a few GitHub templates related to plugins to do with CMake, to do with MIDI plugins. So I have both tutorials and repos about that. But yes, this is actually something that's going to happen often. Like this particular library is about drivers, which is not plugin related, but there will be quite a lot of content here related to plugins. It's quite a topic that's dear to my heart, and I will be implementing a lot of plugins, a lot of plugin related content. Okay, let's go back to my IDE here. Oops, it's in the wrong window. Here we go. Okay, let's see. Am I back? What's up in here? Okay. Why is my code not highlighting? Let's close it and open it again. See, right when doing a stream, CLion decides to act up. Let me do something nice here. I'm going to regenerate this. One of the things I've set up here, maybe it's a good time to show this. So one of the things I've set up pretty early on here is that I set up my build system. It's very, very simple, but the one thing that it does that is important is that I do this thing called find package RT audio required. And what this does internally is that it searches for a script called find RT audio, which I wrote. It's a great script. It just does one thing. It uses this library called CPM to bring RT audio from Git. So it's going to go to GitHub, get RT audio. I probably need to do something else later for package management, but this is a simple way to do this because you can also hook this up locally. Like you can say, instead of going to GitHub, you can actually pass a command line argument that says, oh, don't go to GitHub. I have it on my drive already. So it's a very convenient way to do this kind of setup from CMake. Okay, great. So now that we got this, I'm going to go back into my amazing backend library. So I wrote this thing called native formats. And just to bounce back, this is meant to replace this bit mask. Like this RT audio format thing is actually, it's actually an unsigned long, but it could contain one of multiple versions of this. So it's basically a way to declare which types you support or want to have support. Like we want to say that oh, sorry, which type in this case the device supports. So for example, if you have your input device is going to be your internal driver, or you have some more fancy sound card or something, it's going to report, I guess 0 or more of these that it supports. I can say, like the device can say I do 64-bit audio processing, or it can say I do float 32-bit, or maybe it does all of them. So it's one of a few options. Yeah, so let's think about how I'm going to do this. So one, because I'm trying to think of how this is going to be used. The idea is, I think, this is interesting. What I think is a user will grab the device information, like for example from a settings window, and you're going to get all the different options for devices, your internal sound card, your external sound card, and all that, and then the program will have to say something like, hey, is this device suitable for this, to think if it's going to show it or not. Like the program will say, hey, you're going to get a list or a vector in this case of these devices, and the program can say can do some decisions about this once it knows which formats the device supports. So I think what I'll do is I'll actually set this up as a map, and the reason is I think the user would question this map with an actual format that it has. Like it would have this thing, the format. Let's see if I can find it. Something like enum class format. I like this type. Let's move it up here. So I just copy paste it because this is going to be used right here. So I think the user would have one of these few types that it wants to support, and it would kind of question the map. It would say, hey, do you support this, or do you support all one of these? Like it's going to be some sort of interface like this. Yeah. So the way I think I'm going to do this is, this could either be, I guess the simplest way would just be a vector of formats. Yeah, let's do that. Maybe not a map. Maybe that would be nicer. So I'm just going to have a stud vector of formats or something. And by default, it's going to be empty, so you support no formats. But maybe I'll have a few. I can just have it like this. Just have this type without having anything else. Yeah, let's start with that. So I'll have it as helper functions. I'm just gonna have this as pure data here. So this is gonna be, I'm still gonna call this native formats. So I'll remove this library type, and what I'm going to do is, sorry, have a cup of coffee. Good. And now this is going to fail to compile in my real use case of this, because you can see I can't just now when I give it back to the RT audio type, which is the underlying library here, I can't just do this. I'm going to need to write some function that converts this to this. So first of all, what I'm going to do first is I'm going to make a little type, like I got format, and then I'm going to do something like using formats equals stud vector of format. I like that because I think now when I use functions that take this type, later if I switch to another type, not a stud vector, it's going to be easier for me to change, and it's going to create more uniformity. Oops, sorry, not here. Here, formats. Good. And now what I need to do is I need a function, just like I did before, that takes formats and returns the RT audio, what it was, format something. So something like get formats, and takes my formats by const reference. Yeah, so I do something like get formats, and now I'm going to need to make this into a bit mask. I always hate the syntax of bit mask, but basically what it means is I'm going to have this kind of result. The interesting thing is I would also need to kind of convert this thing, RT audio ascent blah blah blah, into this enum version that I have. So I will need to do something like this, basically. And you know what? Maybe I've done it already. Maybe I've done it before. Let's see how this is going to look like. I probably did some mangling with this format. Here it is. This looks nice. So I have a function I wrote before. Oh, this is not this thing. This is something else. Maybe I did this thing before. Format. There you go. I already wrote this. Get format. So this returns the corresponding type. So this is a switch case over my or user provided enum, and it returns the raw thing. So I already have that function. That's nice. Let's go up and put it here in the top. Oh, double pragma once. Come on, I'm not making any sense here. Please ignore this horrible code. There's going to be a lot of intermediate passes here. That's one of the fun things about doing live coding. I also want to shout out a couple of people. So I can see on Twitch here. The Impel Void, the Impel Void said hello, or allo allo, which I think is hello in the language. And also I see some Arthena here, which I think is Elenda from the audio programmer Discord. I'm not sure if this is her or not, but I'm just assuming. Okay. Just to give again previous context to people just tuning in, I'm making a driver library. This is going to be a wrapper for now, a wrapper around RT audio with a hopefully nice interface that can be help to make very easy standalone programs that just load up devices, change the devices. If you need a UI, connects to some UI. So this is meant to be something like this that will be free and open source. It's not going to be an audio framework or anything. It's just going to be a solution for this one thing, for drivers. It's going to be something that if you build some audio program, you'll use this maybe as a building block. That's the goal. Okay, so I have this thing called format, and I have this thing called get format, right? And now, let's go down. I have this thing called get formats. This is interesting. So format is something that needs to convert from formats, which is a stud vector format, into almost like a single get format thing. And the way I'm going to do this is with bit shifting, bit how do you call it? Bit operation. So all I need to do now is I need to go and loop over the formats, and then I can just do. I need to put in the result first. Result, and then I just need to do something like result, and add the format. Or not the format. Get format. Here you go. And what's the problem here? Oh, might not get initialized. Let's initialize it with nothing first. That's great. And then just return the result. So this is basically, I'm reusing this previous function that I have. Basically tells me that I have to make this free function inline. This was the yellow line that was here before. So I'm just reusing a function that I've already used for a previous use case of this get format, which translates my enum into the raw integer, basically, unsigned long. And then I converted this from a vector of those using these bit operations into the type that's required by RT audio. Let's see where the use of this was. Use was here was when I did the same thing with the higher level type. So I'm just going to go get formats and take this here. The other way around. Oh, right. Because here I actually need to convert I need the other way. I need to convert from the low level. Because so I did this the opposite way. So here, what I need is I'm getting actually this, and I need to break this down into my own vector of formats, right? So let's see how I'm going to do this. So what I need is I'm basically, instead of doing this signature, I need something that returns a formats and takes this RT audio format, which I can just pass by value or something. Format. So this is the result of this is gonna be formats. I'll answer just one question here to Sam Arthena, who I know as Elanda. So what's this driver doing? Just make sure. Hopefully the driver is not going to touch anything that's related to actual driving. It's just making a sound. So just to give you some idea, I have a temporary version of a use of the interface. There's an example app here, and the idea is this is pretty much the simplest app that you can write, and this is even more wordy than I expect. But the idea is that there's a very, very simple setup. You create a config, you pass an audio callback, and immediately you get an audio callback here in another thread that you can use to make audio with this. So this is what the driver is doing. It wraps RT audio and it gives you like a clean API to touch audio drivers with all the settings that are involved with this, and then get the audio callback to some real-time audio. Yeah, so this would be like a basic building block for an audio app, I assume. Okay, so back here and try to realize what I want to do. So instead of this crap I started right before, I need to do something else. What I need to do is I need to extract the bits in here and see if those bits exist, see if those bits exist, and then if they do exist, put them in the formats so that my user will read this really nice vector format instead of these raw things. So let's see. Now here's I never remember this stuff. Does anyone know here in the audience how do you? So I have this thing, right? This is my input that includes a bunch of bits, and I want to extract or I want to kind of do an if statement on specific bits. What's the syntax of that? I never remember that shit. Or maybe I put it in the back of my mind because I never wanted to do this, right? So how do I do this? Does anybody in the comment section knows? Okay, so I think. Right, so I forgot how do you call it. You called it like a bit when you use a bit mask. Here you go. So Ilana told me. So it's bits flag, and you see here's all this. There's all this. I never remember the C syntax. Right, it's like bits flag. Right. Let's see if that's true. I'm gonna make an experiment. See if that works. Let's write. I always like to try things in a new C++ project with nothing. Oh, it opened it in a completely different thing. Oh, I can just push it here. Here you go. I have just a C++ project with nothing. This just helps me to see if I know C++, right? And the answer is always no. But I'm gonna test my knowledge here and fix my knowledge. So I have let's decide that I have some let's call it this is gonna be like my bits, right? And let's say I have a few, something like they had here. I have something like, first, and this is something, yeah, and first equals, it's like 0x. How do you do this? I never remember the syntax for this stuff. Here, I'm just going to copy whatever it is that they used. Here it is, 0x1, so the first bit, second bit. 8. So I guess it jumps by 2. Very good. So I'm just going to take. I'm just really gonna steal their syntax here. You can see how much I hate programming in C and like all these like low level stuff. So I'm going to select first bit equals this, and second bit equals this. and the idea is if I have something like an int bits equals something like first bit, second bit, do some bitwise operation here, I should be able to do something like, if, let's just for fun add the second one here, just let's call it third bit, right? That used to be the third bit. Here we go. So if bits ampersand first bit, let's do something like cout. First, then if bits second bit, right? Pretty much this. Second, and then third. So Alana says that she always confuses this ampersand and whatever you call the other one. I hate this stuff. I hate all these like symbols and stuff. I never remember which one is correct, right? But I'm just going to do this, and just for fun, right? While I do this, let's just do something much more normal. Let's do something like void bit compare. Takes int bits, int bit, and if bits bit, let's do something like also let's do cout. Stood string text, then stood cout text, just for fun and to make sure that I know what I'm doing in case I make a mistake. So I'm just going to do something like this. If bit compare bits first bit, I don't even need the if. I'm just out here. Just bit compare first. That's nicer. So bit compare second, third. Here you go. This is my amazing program now. Let's run it. Let's see if I got this correct. Maybe I didn't. Here we go. So I got this. This thing had the first and the second, and only the first and second tests passed. So I think this proves that Alanda's comment was correct, and this is how to do bit compare, right? Let's do this for fun. Let's just do third bit, and now the first right here. And if you can see that, oh, you couldn't see that before. Let's do this. Oh, this is gonna be nicer. Good. Okay, hopefully this will be shown. So now the first and third are printed. Okay, let's try this again. I'm going to do, second, right? Second and third. Let's run this. And second, third. That's good. Let's do all of them. Or let's do none of them. It's going to be fun. Let's just going to do bits equals 0. Right, basically nothing. Yeah, so none of them passed. That's important. And then let's do first, second, third. So now all of them are checked. Good. So now I know how to use do these bit task compare. I'm actually going to steal this bit compare thing. This is going to be fun. So I'm actually going to write a function that I'll copy to my actual project, just because I hate doing anywhere else. So let's do something like template. Type named bit type or something, and bool bit compared takes a bit type bits and bit type bit, and return bits bit. And I'll do this because I think this is way less error prone. So this is gonna I think it's going to be way less error prone than doing the manual thing every time. So here I'm just going to do if bit compare bits bit. Let's see if this works. Good. First, second, third. Let's remove one of them. First, third, which is what I had here. So this is correct. So I'm gonna steal it because I think having this like wordage as much as this is extra words to call, I think this function, I'll make less mistakes by doing this. I think this is better. Yeah, and while I'm at it, let's just make this complete. Let's add the same thing with a bit add, right? Just like so, instead of just adding them here, I can do something that connects a bunch of bits. Yeah, it's gonna be more complicated, right? Because I'll need yeah, let's not do that. I need some more complicated temper. No, let's not do that. Let's just skip this. Okay, I like this. Let's go back to my real project. I'll keep this empty C++ thing open. And okay, so I'm going to go back to my actual code. And what I'm going to do is I'll have this function right here. It's probably going to need to move to some utilities thing, but let's keep it here for before I start to clean up this horrible mess of a file. And so what I want to do is do something that's the opposite of this. So I need to let's see how am I going to, yeah. So I need to say if the format is there, right? If this is there, push this, something like that. So it's going to be something something like if bit compare this is formats actually, not just one format, even though the type is misleading. If formats and do this, right? Then result pushback my version of this, right? Int 8. And this is basically it. Let's just make a clean function for this. So let's make a function that says, let's do something like, yeah, add format that takes inline. Format takes formats as the output. Formats. It takes this as the bits and this as the bit. And then I can just do this as one operation. So if bit compare, this has to be by reference. So if bit compare bits bit, then formats pushback, or I can just do place back. Oh, and I also need the corresponding let's call it, yeah, format. Then push the format. So this is basically the call, and then I can just make this as a straight line operation. So I simplified this if, because this would look like this. This would look like 16, right? Taking 16. I'll have a bunch of these ifs pushbacks, if pushback, and instead now I can do add format. It will take formats. This will take the result, or not the result. It will take the first the result, then the formats, then whatever RT audio this, and then the format int 8. And now, because I already wrote this, I just realized because I already wrote the conversion from this to this, I can just reuse this. So I don't even have to write the bits here. I can just pass the format, and the bit would be get. How do you call this? The bit would be get format with the format. So this is the bit, and I can just compare the bit like this. What is it not like here? I don't know if I like their. Let me remove this inspection. I don't like it. I don't want to remove. I think this is more readable. Good. So I got this, and now now that I have this, I can just have a bunch of calls that look like this. So, right, I can just do this. 16 and 35. I can actually do this in a for loop. This is going to be fun. So I can actually do something like this. This is a very horrible. Yeah, I'm just going to write it manually for now. I'm not going to do this anyway. So I have 8, 16, 24. Right, here's 0 from 24 here. 32. And then there's float 32 and float 64. And here it is. This is my get formats call, and here's how it's used. So get formats that takes this. Good. Let's see if this works. All these calls, this actually works. Hopefully you hear the white noise. All these calls actually get used because I have the example app, right? I have the example app, and it makes calls to actually something that's passing all these types already. So I didn't need to create a use for this because the use already exists. I had a use that was like just horrible, and now I'm cleaning it up. So let's commit this and say added type for the list of formats, or native formats in this case, I guess, with a conversion to RT Audio's natural type. I don't know, something. Okay, great. This is my commit. I pushed it. Great. By the way, this code is not public just yet, but once this gets a bit more cleaned up and makes sense, I will make this all public, free and open source without any. Elena says, why aren't you using std bit set? The thing is, I don't want to use the bits. The bits are actually enforced. Let me show her a comment because that's a great one. Yeah. So Elena says, why aren't you using std bit set actually? Yeah, so the idea is I hate the bits. The bits are used by this library, and I think it's a very C style, very error prone way to do this. So I can change the library. I don't want to fork RT Audio so that they use something else. I want the user eventually to use the my type, right? My type in this case is. You know what? Let's show a use. Let's show how this would be used. So the use would be something like, let me just remove this open stream and blah blah blah, right? Just comment this out for a second. So I open a manager, and then I do something like manager o2 info equals manager.get default input device. I think this should give me this info. Great. So this is basically all I need. I'm just going to put a breakpoint on the last exit so that I'll see what this returns. Let's see what this says. Okay, I'm breaking. And let's see my, the description of this. So now you can see my type, which this thing queried the sound card or the sound cards, and gave me something that needs to be worked with. Now, as a user, I want to work with it. So now you see I have a list called native formats. It's a vector, and it's float 32. If this was a bit, this was just show as bits. So I wouldn't see how many are there. I wouldn't see what happened. I would have to kind of mentally work with this back into a list of things, because what happens is I need the user of this code to do some logical decisions based on this. Like the user needs to say, well, the device told me this. Let's see if it's float 32. Let's see if it's int. Let's see whatever. Like the user code would actually need to do some higher level work. And if this was a bit, I would just see a number instead of this vector. It would just be pretty raw and not very descriptive. So I wanted something the user can easily read, easily compare with in their own code. That's why I'm trying to avoid all this bit operation, unless like there's some really high-end performance thing. But there's really no performance thing here. This is really all just configuration stuff you do when you change the device. You're not gonna run this code every single sample or something. It's just something pretty high level that's meant to help you prepare the real intensive call, which is the audio callback, and that happens later with a completely separate type called audio callback info for now. Okay, good. So I think we got this work to be pretty well. But now I need to do what I intend to do, hopefully, in steps, is start to make sense of this horrible project structure that I have. So what I need to start is, and the reason why I did this separation is, what I need is, I want to go here and start to slowly have a clean interface that does not have any RT audio in it. And then some other place I would have some translation between RT audio and the user code. I'm not there yet. There's a lot to do for this to happen, but I'm just going to start. So you have this thing called make a sound. Let's do something like, I'm going to start creating just a header. So let's start with something like device info. I'm going to stuff a bunch of stuff in there, which might go to some other file. So let's start with device info. H. It's going to have my ones. It's going to have the most important thing, which is my namespace called make a sound. And let's start just stuffing stuff in here and see if I can move the types around. So I'm just going to go here, and I'm going to need this bit compare function. Do I need this bit? No, I don't need this bit compare function. It's not really. I need format. Right. Let's start with that. I need format. I need formats. Right. But I don't need all the conversion functions to go into the header. I just need something like this. Let's start with these two. I would include here something like include device info. Alan says that she's using a template to set up the namespace and all that. You know what? This might be an interesting discussion at a later point. I've tried that, and I've never found a template that I never had to change. But I can probably do one for the Pragma once. The namespace, I always find that it's, or maybe I can do something with the namespace, so that the problem is I need something that will ask me for the namespace. Anyway, I think this is all like workflow things that can be done. I definitely need to improve my creating file workflow in this case. Okay. So let's go back here. Let's reload that. It should hopefully see that and parse the types, or it's going to go quite crazy on me. Now there's sea lion nova, like nova bugs, I guess. Am I going to force it to reload? Forgot. Anyway, so I move these two types over here. Hopefully, pretty soon it's going to give me some actual completion. Or if I close all these tabs, including this one, and then open this, now it's going to realize I'm using this. No, it's annoying. Come on, don't be annoying. Let me just open. Let me just see everything in my file. I'm just being annoying like this. No, doesn't work. Okay, let me, not sure why that happens. Anyway, what I could do, maybe oh, here we go. Once I type something, it cleared itself up. Okay, so let's just include vector. And I'm going to start by, you're going to see a lot of that. I'm going to just move clean files or clean types in here. And then the backend, what I call RT audio, will slowly, get rid of all these types. So I have this type called device info, which I think does not have any RT audio in it, right? Good. So I can just move it over here. Oh, sorry. It's over here. Good. So everything, no error messages here because this type knows nothing about RT audio. Awesome. Very slowly I will have good separation here. These are RT audio types. It's called error. Oh, you know what? No, this is my type. I'm going to move this also into device info. This is my error type enum. I can just, see what else is here. So this function again converts my converts RT audio's error into my error. More boring switch cases. Get default num channels. This is actually my function. You know what? This is actually important. I probably need this. So this is all in my stream parameters. These are all my types again. Good. So the proof that all these are compiling. Let's me just do some inline here to make CLN go quiet. This should be unsigned. Oh, it just says use static cast. Sure, I can do that. So so now I have these non-error types or non-error structs. What is this? Oh, flags. Here you go. This is another one of my types. So slowly but surely, I'm creating a clean POD style structs. All these are just plain old data. They can just be copied. And now there's going to be some other. Here you go. This is good too. Stream options. That should be here too. What else? Oh, something's not compiling here. It doesn't know what error is. Did I not copy error in here? I hate copy pasting. I did do that. Here it is. Error. Right? Where did I screw up? Screw up something. Okay. It just took a while to figure out that I was doing everything correct. Good. So I'm just going to go on. So what I'm doing, just to give you, again, context, I'm cleaning up all the types that I've used here so that there's separate files. For now, it's just going to be files, but just separate files from my interface types and the RT audio interface types to have some separation on what belongs to them and what belongs to me. So the other thing, I did all of these here. There's something here about the config, some structure about the config, right? So much crap in this file. Let's see. So I just have the audio callback info. Oh, stream config. Here you go. Stream config. That one should be here. And that thing requires, oh, here we go. That's weird. Okay. This is, oh no, this is actually not weird. So this is just my type. I thought this was like some type from the library, but it's not. This is just me using, So first of all, I want to say hi to Paul here, Wave Sequencer. Wave Sequencer make an incredible modular synthesizer called Hyperion Synth. It's awesome. You should really check it out. It can do quite a lot of cool things. Maybe one of these next few streams would be I'd like to bring Paul, if you'd like. I'd like to bring you to do some co-hosting here, and you can show a lot of what you're doing because it's quite awesome. I think people are going to love this. But yes, so in terms of summarizing things, I did summarize it a couple of times. What I'm doing here is I'm creating a library that for now it just wraps RT audio with a much nicer interface. And the idea is that it should help you create something to do with audio drivers. So I'm just going to give you an example here. So the idea is with this very small program, just this, you can immediately in a console app or a GUI app bring up drivers, connect to, set up everything, connect to an audio callback, and do some real-time audio. So this is meant to help to help whoever is doing some real-time audio program like a DAW or a standalone version of a plugin or something to write this. It's similar to something that Juice Audio Device Manager does. And I will actually be using Juice Audio Device Manager as one of the possible backends, probably. So it's just meant to give some nice, clean interface, so that you don't have to worry about a lot of the setup that's needed to make this happen. That's really the, I guess, the goal of what I'm doing here. Okay, so thank you, Paul. I'm actually really happy that Paul is here because what Paul is doing is pretty unbelievable. Like he has modular synth where you can chain a bunch of modular patches and create this one big patch. It's pretty amazing. And I will probably go into I'll have him over and we will do a review of what he does because it's quite fascinating. It's quite a heavyweight piece of work and one of the most artistic, I think, interesting plugins out there. Okay. So back into what I'm doing. What I'm currently doing right now, the very mechanical part, is I'm just moving all the types. I initially created a very low-level raw implementation where I stuffed pretty much almost everything into one file. It was horrible. But what I did was I wanted to move all the types and remove all the RT audio types from this implementation. But I just found out a problem. So in this struct, I still have one status, like an RT audio stream status. Let's see what that is. Oh, here you go. Might be another bitwise thing, right? Or is this just a value? Overflow. I think it's just a value. And in this case, just an unsigned int. Okay, so I'm just going to do the same that I've done in other places. I'm going to switch this into an enum, something like enum class. It's something like audio callback results, and it's got, if I understand correctly, it's got nothing, which this doesn't show here. So one option is nothing, and the other option is that overflow and underflow, right? Yeah, it can be one of the following two options. Whether this, let's see, notification of a stream over or underflow is indicated by non-zero stream status argument in the RT audio callback function. Okay, so this is for the actual callback returns this result. I'm actually probably will be hiding this from the user, and I will do some other way of doing error reporting. But let's explain a little bit of what this does. So so the enum option is basically the default result is basically okay, like there's nothing wrong. This is a way for the user to report that there's been an error, like or something like that. I think this is what this is for. At least this is my understanding of this, right? So notification of stream over underflow, on zero stream, status argument, stream status can be one of the following two options. I'm not sure if the user is supposed to be writing this or receiving this. But anyway, I'm just going to start just converting this in a simple way. So I'm just going to start call this okay. What are the options to say? Input overflow, output overflow. So input overflow and output underflow. So input data was discarded because of an overflow condition at the driver. And output is the output buffer ran low, likely causing a gap in the output sound. Okay, interesting. I need to learn more on the low level of what this is, but I'm just going to forward these calls for now. So it's input overflow and output underflow. So I'm creating this so that I'm going to move this away from the RT audio. Oh, let's keep this here for a second. Let's switch this. And just a reminder, I did this so that I will not have any kind of RT audio types in here. That this would be clean and I can move it away. I got it. This looks good. And now I can just copy this whole thing. I would still need to do some type manually with this. So let's move it here. Good. And what else? Oh, get num channels. Get num channels is probably a function that belongs in the library space. It's not about RT audio. Good. And I think this result thing that I just added, I also want to give it some default. So the default is audio callback result. Okay. Good. I think now pretty much everything should compile. I'm not sure it's going to work actually because there's something that I have that's missing. Oh, you know what? It might not compile. Interesting. It might not compile. I actually know why. Yes. So what it did was it says I cannot, in my usage of this, because what my usage of this is when I open the stream, I translate all these types to RT audio types. So I didn't, I do this like, this is like a big translation thing that I did in there, inline. Why did I do this inline? That makes no sense to do it inline inside of the callback. So let's write this translation. I think this would be a good time to do this. So I need to take some of these actually come in from the audio callback itself. Like in every audio callback, I get stuff like how many frames or samples are there, stream time. Those things happen are coming from the library or from the device. But some of these are coming from my own code, which is I guess a translation and the config things that comes from myself. So Alana says that I'm also a pod equals initializer. Yes, definitely. I would definitely like to do trivial operations over pod. Pod is, by the way, is another way to say plain old data, right? Pod is plain old data, and the idea is a pod is something like, it's something like this, like a C type or a C struct with a bunch of bools in this, or it's a thing with some, ints in there or something. Technically, some of my types are actually not bools, are not pods, because I have something like a std vector in here, which is still it's still data, but std vector is std vector of int or something is actually a more heavyweight type, because it has like a special constructor and a special move constructor, or all kinds of like operations where something like an int or something would not have this, or string is also a special type, but it is let's call it a C++ POD, in the sense of it's a trivially copyable and trivially movable object. Like you can just move this thing around, copy this around using some default assignments. You don't need to do anything special to handle this type. So what I wanted to do here in my backend is doing this data. This is going to be here. This file structure is a mess. Okay, so here this kind of a complicated function, probably the most complicated function in this wrapper. I do all kinds of when I open the stream, I do all these like steps to create a callback. This is going to be the real-time audio callback that the device will later call me. But I do all these data conversion thing to make the data work with the RT audio data. This is, by the way, where something I need to hide from the user, because the user might call this thing OpenStream, but they never want to see these types in their code. They never want to include directly RT audio or something. They just want to pass a callback with my type that they included without having any exposure to the backend. So here I did this thing that you can see. Basically, all I did was I'm building an audio callback info, and this probably should be a function. This is kind of, I don't like this. So I'm going to write this function right here, but I'm going to move this in a second. So this is going to be a function that says audio callback info, get callback info or something. Return info. And now I'm going to pass a bunch of arguments so that this could be built from whatever is coming into this function. Basically everything that's known in this local scope, I guess. So what this needs is, you see there's Buffers. Wait. Oh, right. I'm still storing this void pointer. Interesting. Yeah, so Anila says, am I C++ 20? In my code, I am C++ 20, but not in this library. Like this library is, I'm not sure what I'm going to require, but I think C++ 17 would be a better choice, because C++ 20 compilers are not as spread out, and I don't want to make something that's going to fail on too many people's computers, especially people using Linux and other OSs, which this will support. So I want to make sure this will easily be compilable, and maybe over time I will update this into C++ 20 compatible implementation. But anyway, all this stuff, the interesting thing about all this stuff, like there's some ugliness, this library itself, like RT Audio, is actually very much, very close to a C style, even though it's C++, it's very close to C style interface. So hopefully what I'll do is provide a very, an interface that does not do all of that, even though I will do some horrible things in my implementation, just like you've seen, like all these bitwise operation and whatever. So I'm going to try to make this, not make this library itself be too much dependent on C++ types, except for things like vector, string, optional that will be passed in the interface. Optional, I think, is C++ 17, so I think that should be okay. Anyway, so what I'm doing here is I'm going to be let's see. Okay. Okay, so I need to have like a clean function that translates the whatever happens into a callback. So okay, so what this needs? So I need to convert the status. That one is important. So I need a function here on the back end where I have all these horrible conversion functions. Here I need a function that converts RT audio something. There's some status thing. Here you go. Stream status, get status, and it takes my stream. How do I call it? Audio callback result. I guess maybe status would be a better name for this, right? Let's change this into status. Audio callback status. It's a better name. So the status takes a status and returns something of this type. So I think what this should just be doing is a switch. Let's have CLAN auto-generate the statements, and I'm just going to return the different types. Let's see how they're called. One is, if it's okay, just return nothing. If it's input underflow, return this, and if it's output, returns how's it called? Output underflow. Okay, so return status. I'll just do this as well. Return not status, return result. Here you go. So this is basically the translation function. Now I can go back here. First of all, I can just do something like get status. All right. Get status from, sorry, this is, oh, sorry, it's the other way around. Okay, the other way around. That makes sense. So instead of doing this, I should actually have a function that returns my callback status and takes in the RT audio format. So this should switch on this, and if this is the case, right, this should return this. I can probably just avoid the switch here. Just makes no sense. There's two things here. So if status equals to this, return audio callback status, input underflow, and I don't even need an else here. I can just do input underflow. And you know what? I don't even need the result thing here. I can just make this, I can just do this, and then return audio callback status. Okay. This is RT audio. Output under, no, sorry. This is, I'm confused. Input overflow, this is output underflow. Remove this. There you go. So if it's output, return output, input, return input, return okay. Good. So now, here we go. This compiled. This is fine. Now let's make this whole thing a function because this is pretty horrible. I just hate this. I would just do something like, let's see. So I've got this function here. This needs to have input, output, end frames, stream time, status, user data. It pretty much needs all of this except for user data. Instead of user data, the reason why this user data exists is that basically it gives me something that I passed into this. So it's actually quite a low-level implementation detail of this. When you open the stream, it asks you to give it a callback, but this callback is very annoyingly is a C function or a C function pointer. Let's show you how this thing looks. So that thing takes an RT audio callback, which is a very raw function pointer. The problem with the function pointer is that unlike a C++ callable, this thing does not allow you to store something in the capture list. So if I wanted to pass, for example, I wanted to pass some information about my type, I want to pass some pointer for the class that calls it, so I can use class members. I can't do that. This is going to fail compiling. It was a very annoying problem to solve. So what I did instead was that I passed it just a pointer to the this, and then later when I do the callback, this is like a captureless callback, right? Basically knows nothing about the outside of it. Then I cast back into the manager, so I can kind of restore things from the config. That was basically the reason for this. So I'm just going to, but in this case, in this function that I made right above here, I can just ask for the config. So it's going to be something like const stream config. And this hopefully will allow me to just copy this entire thing. Yeah, right? So I just need to do this, just copy this here. Good. So all I did was create a very simple conversion function. I'll move this into the rest of the conversion functions of the backend. Make it in line. Life is difficult with header only. Okay, so I will do this, and then I can just do, how do you call this function? Get callback info. So I can just do something like auto-info equals get callback info, where I will basically pass the world, output, input, end frames, stream time, status, and manager.config. And I can just erase this horrible piece of code, which is pretty horrible regardless of how you look at it, but it's less horrible now. And now this is the callback. So the callback will get the callback info and then call the, you know what? I don't even need the manager. Let's just do something like this. So auto config. Auto config. Manager.config. config. This. So I do this, and I'm actually going to improve this a little bit once I work on something important, which is to get this callback out of the config object. Good. Let's see if I got everything correct. Let's see if this is going to compile. This compiles. See if it makes sound, or did I do some horrible mistake? Awesome. Hopefully you're hearing this awesome white noise. I was trying to make it not too loud, but there is sound. It opens the device, plays sound. My refactor, or the initial stage of the refactor, kind of completed. Let's commit this. So I started by, so it started moving all library types that aren't dependent on RT audio into their own file. Okay, so what I just did is that I created this very let's call it a POD style header. You know, all these types are just boring C++ types, unsigned int, you know, strings, vector. Let's hope formats, which is my type def for a vector. Enums, that's good. There's a couple of helper functions there. Maybe I'll move them somewhere else. This one has a custom constructor, which is probably need to remove it. That constructor is mostly to help me create the default. So it's probably not needed by the user to do this. It's a simple thing that I did to help create like the default setting, I guess. Flags, stream options. Yeah, so these are basically all almost. Yeah, these are pretty good. So these are now self-contained files. Like they only depend on the C++. You know, there's only one include here called for vector. Everything else is types that I've built in this file. So nothing depends on RT audio. And then there's a very horrible file somewhere else that does, you know, conversions, right? This thing converts from my status into RT audio format, right? Like a status that they want. Is it really a format? Oh no, it's not RT audio format. Oh no, good thing I know that. It actually should be stream status. It actually doesn't matter because they're all the same type, but you know, this was a mistake. So good thing I reviewed that. The callback info translates, you know, the audio callback. Sorry, the info that's passing to callback from whatever RT audio passes into my type. It's basically just a bunch of data mangling to help with the user interface, like the coder interface of this, and to help, with simplifying the operation that the user has to do. Okay, so now let's go back to the actual operation the user has to do. And I want to simplify that as well because I think that there's definitely too much or too many of those here. One thing that I still have here, if I go to this make a sound thing, see there's a class here called device manager. Right, how do I keep blinking out? How do you do collapse all, right? There should be something here. Navigate. No, code. How do I do collapse all? For viewing here. Probably here, right? Somewhere here I can do that. Folding. Here we go. Collapse. Oh, here it is. Okay, good. But I want to collapse another level. I want to collapse just these. It's probably a better way to do this, but no? Still not going to work? How do I get to collapse all these functions with one click? Right, I should be able to do this. Just do one by one. Okay, so I'm just going to collapse this. Still collapse too much. Collapse all these functions. Okay, now let's get an overview of what this does, because this entire class, first of all, needs to be moved to the implementation, but also this class does way too much. There's you see this struct has like 1 million public functions. There's a ton, like there's, I don't know, a lot of functions here. You see get devices, get default input device, get default config, open stream, close stream, start stream, stop stream, get the text. So many functions. I think what I'm going to do now is start to work towards cleaning this up, because a lot of these are, as you can see, they're just like one-to-one mappings of the interface, like close stream, close stream, starts, blah 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 blah. But I don't think the user needs to do all these things. Like maybe they will. Maybe there's some. I'll need to expose some of it. I need to think about this more. But I think I want to start with way less of the implementation exposed, and something that's much cleaner. Let's see. What do I need? So the first thing I probably need to do. Let's see. So first thing I probably need to do is let's see how I use this in the example app. In the example app, I just used get default config. Open stream and start stream. Open stream and start stream. I wasn't sure why there's two separate things. Like first you open it, then you start it. I don't know. It's kind of weird for me. I think I'll just do something like, start or something, right? Start with maybe with the config. This is something like start with the config, right? And what this is going to do is called, open stream config to use, and then start. Something like that. I don't know. It's and I'm just going to move all of these, especially stop, abort. All these stuff can probably be implementation details, or at least be a single function. I don't know. There's a bunch of getters here, show warnings. Like all this stuff I'm just going to move into private. All this stuff. Yes, this is much better. Okay, so now this is my public interface. So get device count. Do I even need get device count? I don't know if I love this. I don't know if I want to expose this. Let's not expose this at all for now, because I can just do get device names dot size. I think that would be better. Get a vector. The vector has the size. I don't need to keep bringing forward this. Okay, so I get the device names. The names is kind of important, I guess, because it's more of a UI helper. Even though you can actually just do something like get devices and then query the names. Getting the device names makes sense, I think, because, like let's say you have a display box, you might just want to display the names of the. Maybe. I'm not sure. I'm not sure if this is such a good interface. I'm going to wait with this for now. You know what? I'm just going to. I might have this as a helper. I might just remove this. I don't need this function. It's all there in the implementation if I need it. So I like this. I like start. I think my destructor for now is already doing stop. It's possible that a stop option, stop public one, so let's do something like stop. If somebody wants to stop it and not destroy the audio. So I'll use this destructor thing I have, and then stop. Yeah. So now my interface currently is get default input device, get default output device, get the entire list of possible devices. This is really what you need for a UI app that creates audio devices. And for now, this is it. Let's see what other crap was here. Something about the errors. Get the sample rate. Maybe getting the current sample rate is useful. Getting the latency. I guess you kind of need some of these. But maybe I'll wrap those in some other objects so that you can just get the object and do that. I don't know. I'll have to think of maybe I'll use like a get info that gives you everything. I'm gonna look into this in a little bit. But I'll wait with all these helper methods, and I'm gonna start at least with just using this interface. And now I need to also clean that up. But let's see if my app will still compile. Does not compile because I've used OpenStream in my example app. Good. Now let's clean up the example app. I'm going to remove this and just say start. I don't need to call stop because this object gets destroyed when the app goes out of scope. So let's run this. Great, I hear some white noise in my driver's work. So this is a little bit better. So this means, I get the default config. I start with the default config. I can, by the way, literally do this. Have it look like this. Oh no, I don't need this because I can't just yet because the callback is a part of the config. I need to get rid of this crap callback in the config. Let's commit what I just did. Removed most API functions to start cleaning it up. Very good. By the way, I know there's some people watching. Are there any questions about what I'm doing? Am I just talking? Do I say things that make sense? Let me know in the comments section, and I will try to answer. Hopefully, by the way, audio is okay and everything is operative. Okay, we have another cup of coffee or another sip of coffee. Okay. Yeah, so the question is, at first I thought you were doing a low-level driver like ASIO. So it's actually possible this would also have a backend that's like goes to that kind of lower level in the future. But I think I'm gonna start by doing something that's gonna help to use existing backends, and the reason is, or existing more, let's call it higher level backends like RT Audio. And I think really this is really what users need. Like as you've seen, like as you can see with my really big implementation files, you can see that it's very wordy to get something happening with RT Audio. They have a bunch of configurations and flags that unless you wrap this with some sane interface, I think there's just too many options. Like you can make it work, but it's not like, it's going to be a few hours of work to get sound instead of this, which is like, 4 lines of code to make sound, which I think is better. I think it's cleaner than, if you see what I'm doing in this OpenStream thing with all the mangling of all the different types and the callback that calls back to me. There's also something about the actual user types. So their callback gives you a void pointer, and you have to cast it back into some useful type. So I was trying to avoid that. So it's so this is the thing. Lana also says that it would be interesting to generate option struct based on JSON files. This is actually what I'm going to do. I don't know if maybe in a couple of steps, because a big requirement for this is to be able to load and save configurations at runtime from a JSON file. So I think this was something that's it's very likely that just like I did in my code, something like, where's my example app here? So just like I did something like, I don't know, start with like start config. There's also going to be a start overload or something with a JSON, right? So that and that will actually do more heavyweight things, because there's some threading considerations, like what happens if you change it from the audio thread or the GUI thread or whatever. There's going to be some other required handlings of this. There also would be things to get the current configuration as JSON, because you want to save it. Like the user did all this settings on the audio device, and then you would want a way to save it so that you can recall it later and not like have the user reconfigure. So that's actually going to be a big part of what this is going to do. But the thing I'm going to do just now is, there's something that really bothers me and also bothered Jules when he saw this. The initial, API of this, is he said, and he was very correctly to say that, he said that the callback here is not good as a part of the config. He said that this should be something separate, and because he also said that it's possible that you want to replace the callback, like you want to start with a specific callback and then pass another one. So what I'm going to do is I'm going to start removing this callback from here, and I'm going to pass it separately. So yeah, so maybe I'll do something like set config and then start as like separate operations or something like that. So I'm going to remove this callback, and things will now stop compiling. For example, this. And instead, let's keep this non-compiling so I'll remember what isn't working. And let's go to my API, kind of API-ish. Currently, the API function is just passing passes a call to OpenStream. So here we go, config.callback, right? I don't want to do that. Instead, let me store the callback directly here. Right, that's what it was, callback, right? Callback is a stud function that receives the callback info. That's the callback. So callback. And then I just directly call the callback. Why can't I just, manager.callback. And now I don't even need the config. I can just do this, save some typing. Much nicer, right? So I get the info, and then I call the callback on the manager object. I can probably extract this whole thing into like a static function or something, right? Yeah, there's no need to do all this. Yeah, there's definitely no need to do all this inline. So I can probably just do something like let's return something int, I think inline int audio callback. And this function just needs to have this crap in it, and I don't even need the lambda. The one thing I do need is I need to know what the device manager is, so I can call the functions. How am I going to do that? I can just have this function declared here without inline, and then implement it right at the bottom. Now manager.config inaccessible. Why? Because it's private. That's because it's private. Okay, I can make it non-private, right? Yeah, I just need to make these not private, at least not private for this particular implementation detail. Let's start with that. Yeah. This whole implementation thing, by the way, should only be exposed internally. Like this will not be exposed to the user in reality. This will only be exposed to the RT audio implementation, which I will later put behind even a more strict API. Might be the next step in this. Good. So I call this, everything works. It says I should probably still use an inline. Sure, I can still use an inline keyword. And then I have the function the declaration here. And here, when I pass it, I don't need all of this inline lambda. And I can just pass audio callback. I think it's going to work. So now the OpenStream thing has less, at least less, I don't know how to call it, indentations or something, less stuff. No member name callback, because now not good. So now when I call this from my app, I just need to do, I need a way to pass this, right? I need a way to pass this into start. So let's have two things. For a start, let's do so that open stream. Yeah, so let's start. I'm gonna pass a callback here. Const callback. CB or something. Callback equals CB. And then when I start it, I can just call start, config, callback, or how do I call this? Audio callback. Here you go. So this made, at least this particular call, made the user instantiation of this library much simpler, right? Because now I can just spawn the manager. I can even now I should be able to even pass the config directly, and I can probably just make this default. But most times you probably won't do this, but this is just simple. So now I even made the interface be two functions, right? The call instantiating the object and then calling my audio callback. And this is just a while loop that does nothing, right? Just waits because the actual processing happens on the real-time thread and not on the main thread. In a real app, probably I would use this continuant of this thread to start the UI or other things that the code might be doing. Good. So let's do something like, what did I do? I did moved. Oh, let's see that it compiles. What am I doing? Is this compiling? Yes, compiling, making white noise. I'm happy. Okay, so what I did was I removed callback from the config object. Moved audio callback from the config object. Okay. And I like this. I need to probably start adding more to this so that you can change the config, or you can change the audio callback, right? Basically, each of those should be a separate operation. But this is a good start. Okay. What time is that? I've been streaming for like 2 hours. Whew. All right. So, are there any other questions? I might take a might go get something to eat. I don't know. I probably need to do something productive with my day. I don't know. So, does anyone have questions about everything that I've been doing? Maybe some general questions about why I'm doing this or why am I doing certain things. Let me know in the comments. I just want to summarize. What I'm doing here is I'm working to clean up a library that helps people very, very quickly. With just a couple of lines, create an audio callback. And later I'll add options to configure this. Like even now you could do stuff like manager dot get devices, and you can get information about it. Like let's see what this does. Let's see, info equals get devices. So you see I have a lot of devices connected. Let's see what they are. So I have the first device is my studio display microphone. It's like my monitor microphone, right? The other one is the display speakers. The other one is my MacBook Pro microphone, like internal thing. Let's go somewhere down the road. What is this? Avid Pro Tools Audio Bridge. I think this is like a virtual device. Let's see what else. Pro Tools. Like there's a bunch of Pro Tools stuff in here. Here it is. This is my RME. It's got 30 outputs and 30 inputs and duplex channels and blah, blah, blah. What else? Oh, here you go. I have some virtual I/O device that I'm using to stream this. So a bunch of devices. So there's a lot of connectivity to be done with this, even before I dive into MIDI. Okay. So Alanda asks, things like this are usually done in C, right? Have you considered this before doing in C++? I don't know if that's true. I think the low-level aspect, like the actual driver library could be in C, I guess, likely in C. But first of all, this I know this is gonna sound bad, but I hate C interfaces. I mean, I guess that, they're needed. Like if I would write a driver, like an actual driver, I would write it in, I guess I would write a C interface. I don't know if I would write C implementations. I think that I would, like, probably if I needed to work with other languages, like if let's say I had to work with something like Rust, or I would want to, I would want to make a generic driver library that would work with Rust or would work with Zig or work with the world, right? Then what I would do is I would make a very, very thin C layer API, and I would expose this with over a something like a DLL or something, and but I would still do the implementations in C++ because I think that the code, like the implementation code in C++ is so difficult in my opinion to work with. Like most of the time when I look at C implementations, you see people re-implementing virtual functions and they're re-implementing all this like dynamic types, and it's very horrible I think to maintain and to work with. In this particular case, I'm also working with C++ existing libraries in C++, but I do think that RT Audio itself, I didn't dive too deep into this. I think I'm using, and I'm working currently with the C++ RT Audio, but I think they also have a C version, right? Maybe I'm wrong about this. Let's see if I'm right about this. RT Audio, let's have a look. So I'm just looking at the code for RT Audio itself. Yeah, so it looks like they also have a C file, right? They have a C interface, which is probably more lower level than what I've used. And you can see it's basically the same calls. Like, let's compare. It's going to be interesting. But it's like, for example, here you go. This is interesting. Like, for example, if you want to get something like the let's see what they did here. It's interesting. Yeah, so first of all, you have no RAII, like there's no lifetime. You have to create, destroy, and pass some pointer or something. So there's a bunch of lifetime things that get involved in the process. You want to get the device info. I guess like there's probably going to be a bunch of low-level pointer stuff that somehow, by the way, exists in their C++ version, but I don't want to do in user code. I think it's kind of like so many problems can happen with pointers in the interface. I think it's people have to keep their structs alive somehow while they do the call. I don't know. I feel like there's going to be so many errors that could happen with this, and I would need to do much more work to wrap this if I would do this. Again, sometimes it's needed for the C part, but I think what happens here is going to be interesting. I don't know how they did the implementation itself. Yeah, okay. So here's what they did. Their implementation is actually in C++. So if you use the C implementation, it forwards the calls to the C++ call. Like, look at this. Here's all the C++ types. All right. Here's the device info type. Here is the stream parameter struct that uses a std vector of C++. So really what they did was they made the C interface for people who use other languages, right? Like they said, well, if you're using Rust, you're going to use this and kind of work your way around this. But they didn't want to, I'm like the real code, right? The real implementations, they're here. You see, there's a 12,000 line CPP file with, SEO and all the different low-level implementations. So there's a bunch of low-level details, and they're managed in C++. And I think that makes more sense. I didn't review their code, like the RT Audio code, so much, but I think it makes way more sense. I can see right away they've used stuff like mutexes here, and they've used a bunch of std strings, std bed alloc for handling allocations, std cr. Let's see what else. Std max. What else to use here? There's probably a bunch of C++ types. So string is all over the place. Vector is all over the place. Stud pair. Like, I think doing something like this without all these stud types is just horrible in C. Like, there's so much bookkeeping you have to do on like the size of the array and the size of the string and memory allocations here and then deallocate them on the other side. Like, this whole code would be probably twice as long in C because there's just because the bookkeeping would be horrible, in my opinion. Yeah, I know this is I know there's people who hate C++ and would write in C or whatever. Like, I know it's a thing, but I don't think it's like, I mean, I would get if you don't like C++ and you wanted to implement this in Rust, like, this would be fine. But in such a low level language like C, I don't know. Yeah, though for embedded, it is counterintuitive. I don't know. I don't know. You know what? I have no idea what the conventions are for embedded, but I do know that many embedded people use C++. You know, I don't know how many. Quite a lot actually. Like, C++ is pretty big in embedded. Like, it compiles on Arduino and low level Linux and stuff. So I don't know how many. I mean, I'm sure there are people in that world who would be answered without the standard most of the time. I you know what? Someone who was more of an expert should tell me that. Like, last I've used Arduino, all the stud types were available. Like, I've done a project with the Rimon School hackathon. That's a music college in Israel, and I was there as a mentor that was a couple of years ago, and there was a project there we've done with Arduino that had like some sensor thing. Like, they had like some controller they were building, and it was built with Arduino, and I was there helping them. I was coding, with them, see what they're doing, and we used a bunch of stud stuff in there, and it compiled. I'm sure there are cases where you cannot use the standard library and it will not compile. But then again, I don't know. I'd be interested to know how much is it actually a problem nowadays. I don't know. Yeah. So there's definitely a discussion there whether it's always available and always not. But I'm sure I can just Google stuff like is STL available in Arduino. Yeah, so there's something called Arduino STL, which is basically an implementation of the STL. So maybe it's not a full STL. Like, maybe there's maybe if you use stud file system or something, maybe it's not going to compile. But my understanding is most of these do compile. But someone who's more of an expert would say. I don't mind so much about this, because to me, I don't know if what I'm doing would even apply to Arduino. Like, I think it would only, like, these kind of audio devices only apply to if you have an operating system. So it would apply to Linux or some low-level Linux, but I don't think it's going to apply to an Arduino, because I think with an Arduino, the Arduino library would take care of all these devices. Like, I don't know. Maybe at some point I could actually use an interface. So what I could do at some point is use an interface like this that would operate with the Arduino backend. But I don't know. I need to rethink all this stuff. Arduino, such a specific type. And yeah, but I actually want to thank you for bringing this up. This is interesting. This is something that comes up a lot in the C++ ways. Like, hey, you do something. Is this actually portable? Is this actually going to compile for these targets that you're using? That's one of the caveats of using. By the way, of using C as well. Like, C is also not portable if you're using like random libraries. C, only pure C is portable, but a C that will call an OS API is not portable, right? Like, if I call a Mac API or a Windows API, then it's only going to compile on this system. So it's like there's all these considerations as well. Like, do you RT Audio, I think, guarantees support with Linux, Windows, and Mac, and will probably by itself not compile on other things. So, okay, I think I'm gonna go get some food unless somebody has another question for me to answer. I need to continue this. I don't know if I'll continue this later today or I'll continue this tomorrow. I think so. Yeah, so there's something about Android here. Yeah, you know what? Yes, that's a very good question. I wonder if RT Audio works, because I didn't check if RT Audio was the situation on iOS. And let's have a look. Let me just go to GitHub and see what they support. So I'm gonna go here and search for RT Audio. It's possible that for stuff like that you'd need the Juice backend, which I will also add after this. Let's have a look. So Case Portman says hi. Hi. Yeah, so I'm just looking. Let's bring up my screen. I'm just looking on GitHub on the RT Audio page. Let's see. Android, iOS. Doesn't look like they have it. So it's possible that for that you would need to use the Juice backend. So what I would need to do when I continue this work is once I will have the interface correct and does everything that it's supposed to do, then I will also have the Juice backend, and then or maybe we'll find some other backend. I don't know, but there will be, you can choose that whenever this is not supported, so you can switch to something more appropriate, and maybe in the future I'll just write an OS backend for these for the Android and for this. Yeah, I think this is a good start. Yeah, so portability is often the final and biggest battle that has to be fought. Yeah, exactly. Fortunately, some libraries already solve this, right? Like Juice already solved the iOS and Android stuff. So I could just say, well, whenever you expand your program from a desktop to a mobile app, then you have to plug in Juice, or maybe plug in something else. Like I didn't research the ecosystem. I need to do more of that. The good thing about what I'm doing with this project is that I'm trying to find a way so that, let's say you write an audio app and you don't want to tie yourself to a framework or something, you can just get sound. Let's say on desktop, right? You could get sound on desktop, because I think that it's so difficult to do now, even if you use RT Audio or even if you use some library. It's just difficult, so much setup, so much control, and you just want to, you just wrote some signal processing, for example. Like imagine something built on top of this, right? And you want to, have a demo for your signal processing library, not even a full app, like just a demo. I think this is such an easy setup to get a callback that shows something cool. Like imagine if you want to show people, you have some oscillator library or something, or like I can very easily spawn a command line app with no other libraries that, generates, like loads a MIDI file and plays it through my synthesizer. I don't know, something like that. Like I can very easily show the quality of my library, which I think would be a lot of how people use this, because like you might not use this even in the products. You just will use this in the demos. I think this will be very useful for people making DSP libraries, I hope. Okay, so Elna says for iOS, would you have to port it to Objective-C or Swift? I mean, if I use a wrapper library, then no, but obviously on the underlying level, yes, right? So, so most of the, for example, iOS native code is Objective-C or Swift. And I think probably what's going to happen is if I use some backend like Juice, so Juice will abstract this my call, do some data mangling, and call the Objective-C layer. It would be nice to just put a very native backend there with the OS provided stuff, just because it would mean less dependencies. So yeah. And by the way, Swift, that's something nice about Swift. Let me show you something pretty cool. Swift actually has now, in the latest version of CMake, Swift has very, very nice CMake where is this opening? My window management get crazy. Here we go. I just opened this a few days ago. It should be here somewhere. So I went to if you go to GitHub, there's this thing called Swift CMake, which is a project by Apple. I just cloned it. New window. Did I change things here? What did I do here? Probably change things for testing or something. Yeah, so where am I? Let's see. Here you go. So they have this project that has these like hello world stuff for, let's do hello minimal, right? Let's load. I think it's a separate CMake file, right? Hello. Here you go. So I can just build it in CLion, and you get a Swift. There's a main CPP file that I added or something. I don't need that. But there's you get a Swift call. You get it in a very, very clean looking CMake file, and you can just use Swift. So this is super nice. I think I had to install the Swift plugin to do that. But yeah, so here you go. So this actually uses a library, like say, will this complete this? I don't know. This plugin actually does not. It gave me an error. I think this plugin does not work so well because it's a beta. It's a beta of CLion, but with the regular CLion, it should work. And you can just interop. So they have some object. Here you go, interop, right? So interop is a project that Apple supplied that will call one language from the other language. Let's see what this does. So you see there's two libraries here, CXS and Swift, right? And if I go to the here you go. This is the C++ one. It calls library.h. And I think it does some, here you go, version, right? So version is going to be resolved in Swift probably. Where is that? Or maybe they did, the other way around. Yeah, so they called library.version. Oh, okay, so they call it here. So the Swift call in this case is calling the C++, the C++ code. So the C++ code, the Swift code does import CXS library, which is kind of defined here in this module map file. It says, okay, this is the header, this is what it requires, link this. And then you can just call. You can just go, you bring up these C++ calls and you can directly call them from Swift, right? There's no DLLs here or some C interface. This is a real C++ interface. I don't know how many types here you can pass, but so this would work. I wonder how this is worked the other way around. I wonder if there's an example for that. Hello world. Let's see what this is. CC core. Let's see what hello world does. Ooh, does not compile. Not good. They have a bug in their code. That's funny. Yeah, okay. Let's ignore that. And they have something vendoring that probably brings in some external libraries. Yeah, but anyway, my point is, I guess, is that Swift is now easier to use in the C++ context. I need to see if that works, like how easy it is to call a Swift library from C++. That would be fun because that would really help touching a lot of these APIs, because I think, like for example, if I Google something like Apple, Swift audio interface library or something, there's probably libraries if it's not the real library, there's probably other libraries in Swift that already do that. Let's call it not audio interface, audio device library. I'm just going to Google that. Yeah, so there are. Not sure. I'm finding some stuff on Google. I'm not sure how much Apple already supplies a built-in version to get the audio device. Would be interesting to find out. Yeah. So hopefully this was useful to people. I'm going to continue this. I don't know. Maybe even I'll continue this today if I have some. After I get some food, I'm gonna do the next step, which would be probably to start serializing this and create a JSON backend for this. This would be fun. I have in the past, like in our modalities code, I have some big serializing library that helps converting all these types to and from JSON. Here, I would need to do some manual coding about this, so it would be annoying, but maybe fun. So I'll come back later for another stream. Thank you so much for watching. Please subscribe if you're watching this on YouTube or Twitch or whatever. And yeah, and thank you everyone. Have a good day. Bye-bye.